DDIA by Martin Kleppman. We're on chapter 2, data models in query languages. Bunch of good stuff in here, but one of the primary notes is that I didn't see a difference between technical data models and business data models. So like an availability model, your uptime metrics, what you're sending into Datadog, and your analytical model, things that have to do with profit and loss, user-facing entities, and so forth. Talking about logs. Logs are data. Events, again, this could go to Kafka or Event Bus. I didn't see discussion of logs or events. And then the idea of redundancy and observability. So this chapter is going to talk about SQL versus NoSQL. But in some cases, you want both. You want some strategic redundancy for availability reasons and also just for interpretation and data consistency reasons. I might have a log or I might have an event, but I want to interpret that event alongside SQL. Or I might see a problem in my SQL query. It doesn't make sense as an analyst, and I want to go refer to my event data to see if pulling the query or if the representation clears up the problem, basically. Okay. Says that the data model is perhaps the most important thing because it informs how we think about the problem. I think tests do this too, and also user experience, user design. So we should be starting our system design, putting ourselves in the shoes of the user. What pain points are we solving? So UX and then tests, but also it's true that the data model will freeze that mental model. Once we've decided this is how we're going to solve it, enshrining a data model does freeze our solution, and it kind of locks in the mental model. So I do think it is important, but I don't think it's the most important. I think it's like second or third. Need to know basis, basically, is how we can decide what to hide. So we talk about abstraction between the database and then the server-side layer and then ultimately to the UI. The UI, we just send it what it needs to know. And this is a good practice for efficient data transaction, but also for security. So we get into the relational model versus the data or the document model. There's a bunch of history in here. He says that there was one goal of relational models. I don't think there was one goal. If you look the paragraph up, reporting, that's a second goal. So, you might pick these for multiple different reasons. The timeline is a little off. The document model is much older than the 2010s. HTML is a document storage. The idea that everything is a file. So this goes back at least to the 90s. I don't know why we're saying that open source encouraged document stores. A lot of the open source document stores that I'm familiar with, or a lot of the open source databases that I'm familiar with is like PG. And then Mongo, which is not open source, would be a popular document store. OOP is the most popular app development language. I don't think that's true. I mean, I think it's JavaScript, which is not OOP. It doesn't feel like a really substantive point. The general point here is that going from a database to your application code is a friction point. And I think he uses the word awkward. There's an awkward translation layer. So that's definitely true. So when you're designing a system, keep an eye out for pain points when you're going from your database to your application code for sure. Many-to-many relationships are a thing, and many-to-one. We get some examples. That's cool. Some history about stuff that doesn't really matter. I mean, codicil, like this doesn't really matter. One lesson from this history is that SQL won because of DevX. I think that's one interesting lesson that comes out of this history. What about simpler application code? Does one or the other lead to simpler application code? The answer is not in general. It's going to depend on your specific application, and I think that's totally true. But we can still get an intelligent default by looking at the economics. SQL is more popular, so we can default to SQL unless we have a reason to go to NoSQL. He says you can't directly refer to a nested item in a document. You can. I mean, just think about HTML. HTML is a hierarchical document representation, and you can have an ID on an HTML element. But this is really true. If you need support for joins, that's a really good indication that you want SQL. XPath will be an example of a query language on the DOM. Schema flexibility in the document model. I actually think this is a pitfall. the fact that types are not enforced in the database itself, and it makes your application code compensate by validation. So that's another reason that I would say avoid NoSQL by default, unless you have a reason to use it, such as you need like crazy write capacity or something. So the practical tip, this is from me, is that PG can do it all. So Postgres, it's open source, it supports SQL, and you can do things like NoSQL, JSON, and even events and stuff. So PG does it all. Start with PG as my practical tip. Yeah, he talks about query languages for data, major gap that he doesn't talk about GraphQL and the importance of the control location for the query. The fact that giving the clients the ability to alter the query has like really important maintainability and developer experience and organizational like velocity implications. He does get into the fact that the DOM, the document object model, is a data store and it has a query language. So he's talking about like CSS selectors, which are a query schema for the DOM. So he acknowledges that web is a data store. But then we should be able to acknowledge that the DOM goes back to the 90s. So the document, like NoSQL, goes back to the 90s. It's not a 2010s thing. Graph-like data models, super cool. This is a great indication if you're dealing with a social graph or geo, like states and roadways. Great indication that you should use a map, or a graph-like data model. Again, when we talk about a data model here, he's talking about like database tool selection. He's not talking about like an analytical model. So I think there's a limited discussion. Some more history, the Cypher query language, not a big deal. Not something you really need to know. Triple stores, Spark Q, like a bunch of trivia that if I wrote this, I would clip out basically. The semantic web, he says there's no sign of it being realized in practice. Yes, there is. This is really important for SEO. Rich snippets on Google, also accessibility. So please do use semantic HTML tags. Spark QL query language, I don't know. I mean, if it's a niche that you need to get into, there's a great treatment here. But personally, I would just remove it. And then we get to the summary. So a pretty good summary here. But another gap that I see is I don't actually see him talking about what makes a good model. He talks a lot of about the differences between SQL and NoSQL, and then calls out special points for the graph database model. But in terms of a business analytical model, he doesn't actually define what makes a good business model, which is like a really important problem. So I'm saying, did I miss it? I think expressibility is a big concern. So if you think about like voter expression in the political system, one person, one vote versus like ranked voting or other voting schemas will give different ability for people to express themselves. And there's an analogy into programming where different models will allow you to see different user attributes and different user values. That's going to be super critical for a business model. Signal capture and being able to validate your improvements. If you ship a program change, like if you change your website, how do you know that you improved your user experience? You need a data model that can answer that question. So this is basically like a big design gap. So I guess that was not the intent of the chapter, but when I think about a data model, those things are front and center to me. Okay, that does it for chapter 2. Follow for chapter 3 coming up next.